Hello and welcome. In this video I'm going to show you how we can use the chain rule to find derivative formulas for trig functions if the angle is measured in degrees, not in radian. Attention! When we say derivative of sine of theta is cosine of theta or sine of x is cosine x, this rule for derivative of sine is valid only if the theta is in radian. Otherwise, we don't have such rule. Here, the theta, the angle theta here, is measured in degrees. And we want to find a formula for derivative of sine of theta if the theta is measured in degrees. Let me remind you that if an angle is in degree, let's say the angle theta is measured in degree. If you remember, for converting an angle from degree to radian, we have to multiply that angle by pi over 180. So if we multiply the value of the angle theta by pi over 180, then the angle is in radian. So we use this rule here. For finding the derivative of sine of theta, which theta is measured in degree, first we convert the angle from degree to radian. How? We multiply the theta by pi over 180. So we replace theta with pi over 180. So we have sine of pi over 180 times theta. And it's not bad idea to put a bracket for all of this. Now we can use derivative rules that we know for finding derivative of this expression. Because now this angle is in radian. What was derivative of sine? Derivative of sine is cosine. So we have cosine of pi over 180 times theta. But this is only derivative of the outside function. You have to multiply it by derivative of the inside. What is derivative of pi over 180 times theta? Derivative of pi over 180 times theta is pi over 180. Because pi over 180 is a constant, the theta is the variable. For example, what is the derivative of 4x? Is just 4 because the derivative of x is 1. Same thing here. Pi over 180 is like a number. When you want to take the derivative of pi over 180 times theta, the derivative of theta is 1, so the derivative of pi over 180 times theta is just pi over 180. Now if here we rewrite this angle in degree again, attention, here this angle is measured, this new angle is in radian. We can bring it back to degree. Pi over 180 times theta is in radian. If we convert it back to the degree, pi over 180 times theta would be cosine, only cosine of theta degree times pi over 180. Attention to here. This angle is in radian. This is in degree. From degree to radian, we multiply it by pi over 180. When we have this angle is equal to theta degree. So instead of all of this, we can just put theta degrees. And this completes the proof of this claim that derivative of sine of theta is cosine theta times by pi over 180. And of course you can put this pi over 180 in front here. Before I finish this video, attention that we have a similar rule to this for all trig ratios. For example, what is the derivative of cosine theta when theta is in radian? Negative sine theta. But can you imagine what is the derivative of cosine theta if theta is in degree? Its derivative is negative sine of theta, but multiplied by pi over 180. What is the derivative of tangent theta? The derivative of tangent theta when theta is in radian is only secant to the 2. But when theta is in degree, its derivative is pi over 180 secant to the 2. So the only difference between derivative formulas for trig functions when they are in degree is that you have to multiply the formula by pi over 180. I hope you liked this video and see you in the next videos.